Good morning. I'm Doug Crockford, and I'm sorry to inform you that for the next hour I'm going to be talking about JavaScript. So when I first became aware of JavaScript over 15 years ago, my first impression was, this is the stupidest thing I've ever seen. 5 years later, circumstances compelled me to start writing in the language, and I wasn't completely happy about that. So like everybody else, I was determined not to learn the language first. I would just go in and start writing it, and I hated it. It was a terrible, painful experience. After doing that for a while, it suddenly occurred to me that maybe I should read the manual and find out what was going on. So I got the ECMAScript specification. ECMAScript is the name of the standard for JavaScript, and read it. And it's a really difficult read. It's not written for people to read it. It's quite awful. But after reading it and thinking about it, I had this epiphany that JavaScript had lambdas in it. It had functions, first-class objects with lexically scoping. That's the best feature ever put in a programming language, and it was in JavaScript. So it was then that I discovered that JavaScript had good parts. This was the first important discovery of the 21st century. But it also made me angry that because at the same time JavaScript had more bad parts per feature than any other language. And it really offended me that it had this strange mixture of goodness and badness. So I wrote a book about that, JavaScript, the Good Parts. And it's an angry book. I look back on it now, and I'm just completely outraged at all of the things that are wrong in it, at the same time trying to explain the benefit of the things that were right about it. Since then, my thinking about this has changed even more. I'm now thinking that JavaScript isn't just a good language. I'm now thinking it's a great language. And it's actually superior to most of the languages that are also in the market. So I'm here today to talk about ECMAScript 5, the 5th edition of ECMAScript, and some of the new features that we're going to see. But before I get into that, I want to talk a little bit about standards. Any change to a standard is an act of violence. It's a disruption. It's a source of incompatibility, difficulty, the need to change. And it's particularly difficult in the web because we're expected to be forward compatible and backward compatible perfectly at the same time, which is impossible. It's mathematically impossible, but we do the best that we can with it. So changing a standard is sort of like putting a knife in a person. And that's not to say that that's never justified, and I don't mean the sense where sometimes people's got it coming, you know what I mean. I'm not talking about that. It's more the sense of a surgeon who will put a knife in you if it's likely that the benefit he can cause from going in you and fixing stuff is greater than the pain and inconvenience and the risk of infection and complications and so on. So working with a standard isn't quite as dramatic as doing surgery on people, but the same sort of care is required, particularly with web standards, because as developers, we have no control over the platforms that people are going to run on. And so figuring out a way that we can improve the language without breaking things as we go forward is really hard. The 5th edition of ECMAScript was approved a couple years ago. And full implementations of it are now beginning to come online. I was very happy to hear yesterday that IE10 previews already have the full implementation of ECMAScript 5th edition. This is a wonderful event. That joins Mozilla's Firefox, and we expect that the other browsers will quickly reach parity. So the 3rd edition, which is what is in all of the browsers now, was ratified by the ECMA General Assembly in December of 1999. That was a long time ago. That was over a decade ago. In 2009, also in December, the ECMA General Assembly approved the 5th edition. There is no 4th edition. The 5th edition defines 2 languages, a default language and a strict language. My recommendation is that in the short term, we be working in the intersection of ES3 and ES5 strict. And in the long term, you should be working in ES5 strict. ES5 strict is going to be the core of the language going forward. All future editions will be built on top of ES5 strict. There is an ES5 default language which provides a lot of new features. and can do some things that ES5 strict can't do, I recommend you not use that language because it will be obsolete soon. You'll also be disappointed, some of you, to learn that the goal of ES5 was to produce a better JavaScript. There was a lot of interest for a while of turning JavaScript into a completely different language, sort of doing a reset on it. That started in 1999, before the third edition was finalized. Work began on a successor language. At that point in time, JavaScript was a failed language. It had not produced much of a community. It had a terrible reputation. And so the Standards Committee felt it had a license to do drastic changes to it in order to try to make it more popular. Sort of like tying a pork chop around the baby's neck so that the dog will play with it, that kind of thing. But since then, sort of surprisingly, JavaScript became a very popular and important language. And so the ability to make those sorts of really drastic changes evaporated. And so instead, we changed the focus to try to make JavaScript better, to allow us to make better use of the good parts. And I think we made some very good progress on that on ES5. So it's not trying to do big things, but it does a lot of nice little things. So first thing it does is it makes the standard conform better to reality. There were some cases where the standard had some language which said that implementations should do something really stupid. And most of the time, the implementers went along with that. But there were a few cases where they didn't, where they seemed to have some sense that this is too stupid, we're not going to do that. And they were right. So the standard is now reflecting that bit of reality. There are other cases where we saw that 3 of the browser makers had done one thing and Microsoft had done another. And we decided in those cases, majority should rule. And so that's going to improve interoperability in this language. Interoperability for JavaScript is already extremely good, but it's going to get even better. There were cases where the browsers disagreed pretty significantly, not only between themselves, but with the standard. And in those cases, we took some license to say, okay, we can change this feature without breaking the web, because nobody on the web is depending on this, because it doesn't work compatibly in all browsers. So again, interoperability will improve. Now, if you're programming well, you're not going to notice most of this stuff, because this affects mainly the edge cases, and my advice is stay away from the edge, because it's painful and dangerous there. You want to stay in the middle of the language where things are more predictable. So the goals for ES5, number 1 was don't break the web. And we're not completely successful with that, but I think we did pretty good. I think the fact is that any change we would make will break something. But we did the best we could. We improved the language for the users of the language, not for people who are critics of the language. And that was an important thing. There are a lot of users of other languages who have a long list of things that are wrong with JavaScript that should be fixed. And should we do that, they would probably not use it anyway. So we didn't do stuff for them. We did stuff for you. We paid a lot of attention to third-party mashups and the security problems that came around that. And I'll talk more about that later. We did not take as a goal to protect stupid people from themselves, because that's just too hard. So stupid people, I doubt that there are any in attendance here, but for those of you who are watching on the video, yeah, we know you're doing stupid things, and we've made it possible now for you to do more stupid things, and that doesn't mean you have to. We tried to do as much as we could without introducing new syntax, because syntax has terrible compatibility problems. If we were to introduce new syntax into ES5, that would mean that your programs would fail hard with syntax errors on ES3. You can't if around that stuff. And where I work, if we get syntax errors on our pages, we don't get paid. So we can't do that. So we tried to make as much of the new functionality as possible be available without the introduction of new syntax. Now, despite that, we added some new syntax anyway, because we just couldn't. Syntax is really neat, and people like that, and so we did a lot of that. So I advise you, don't use any of what I'm about to describe on anything older than IE10, or IE9 I guess will work too. Anything older, it's not going to work. And that's a problem because IE6 is still a dominant browser in the market. So you can't use any of the stuff I'm about to tell you about, even though it's nice. Maybe your kids will get to use it. So first off, we now allow for trailing commas in object literals. Commas are formal. Yeah, you can applaud anytime you like. That's fine. So commas are generally treated as separators in JavaScript, but some people like to use them as delimiters. So now that will be possible. It turns out syntactically it's always been allowed in array literals, but the interpretation differed because of alighting. There is some confusion. So on most browsers, the length of that array would be 2. On IE, it was 3. So on ES5 going forward, it's going to be 2 for everybody. So that eliminates a source of bugs. We fixed the reserved word policy. There was a mistake in ES3 where reserved words were enforced on member names in objects. So you couldn't use them in object literals or in the dot notation, which is nuts. So this would produce lots of syntax errors. ES5 says this is great, but again, you can't use that. We have getters and setters now formally in the language. So getters and setters allow you to have traps which, when you attempt to access a property from an object or write a property to an object, instead it will call a function that you provided and it will do whatever it wants. You can do some really elegant stuff with that. You can emulate the DOM, for example. You can write your own inner HTML function now and can have it trap and do things. This breaks one of the important invariants in the language. It used to be that getting a property from an object or setting a property of an object, it was guaranteed that no other state in the program was going to change as a result of having done that. And so that made programs easier to reason about. That's no longer the case. So now you can be reading something from an object and big disruptive changes can be happening all over the rest of the system. So that's a difficult thing. This is one of the things that stupid people are going to jump on. I expect we're going to see a lot of stuff where, look what I did. Look at the crazy stuff I can do with get and set. But nobody thought of that. Well, yeah, we did think about that, but we decided to let you do it anyway. We added multi-line string literals. I think this is actually a bad part. I think we shouldn't have done this. But it's there. It's in a lot of other languages, so it's very popular, so it was not controversial to put it in. I don't like it for 2 reasons. One is it breaks indentation, because the continued line has to start over at the left margin. And indentation is really important in making programs readable, and so there's that. But the bigger problem is the syntactic hazard. So the first line is okay, and the second one has a syntactic error. Can anybody identify the error? Yeah, there's a space at the end of that line. It's obvious once it's pointed out. But part of my philosophy of programming is you don't want to be using forms that are difficult to distinguish from common errors, particularly when there are alternatives which are free of those errors. We have new constants in the language, infinity, nan, and undefined. Shockingly, in ES5 or ES3, these were variables. So you could change the value of the global undefined value, turn it to 5, and cause programs to fail all over the place. So yeah, we fixed that. That's a good thing. ParseInt's been fixed. So you can now do the parseInt. Yeah, you can bring it on. So you can now do the parseInt of 08, and it gives you 8 instead of 0, which is the right thing. Now again, this only works on ES5. So if you're running this on IE6, you'll still get 0. So you still need to be using the radix operator until your kids are out of college. I'm sorry? We have regular expression literals which now act more like functions in that every time they're evaluated, they produce a new object. It used to be they all produced a common object, so you could get very strange errors when you're doing execs, which cause mutations. There was a problem in ES3 where if you replaced the object function or the array function with your own, that could have an influence over the creation of objects and arrays created using object literals and array literals. And there are some famous security bugs that came up as a result of that. So the standard now says when it's internally making objects, it will do that as though the primordial function still existed. So that's going to make the language more reliable. We added a lot of new methods because it turned out that adding methods is a way of adding new goodness to the language without providing syntax. And so that means you can take advantage of this stuff. And for a lot of the methods, we define them in such a way that you can write JavaScript versions of them today so that if you're working on a browser that doesn't have these methods, you can add them. Now you might wonder, well, how does that do you any good if we're adding stuff to the language that you could have added yourself? It's because the new stuff is faster, because it's all native and good. So it means that you can run really fast on IE10, and you can still run on IE6. It runs badly on IE6, runs great on IE10. I think that's exactly the way it should work. So instead of having failure, we're giving people incentive. So first off, you get JSON now. JSON is now built in. So you got parse, you got stringify. Some people don't like that it's called stringify. That's my fault. You're stuck with that. So it follows the JSON2 interface. So if you're using JSON2.js, which you can get from json.org, it will get out of the way if the browser has the native version. So if you're on a newer browser, it's fast and it's safer, and if you're on an older browser, it's slow and riskier. Again, that's the way it should be. We have function.bind now, which is a feature that you see in a lot of the Ajax libraries. It's a sort of currying function which allows you to create a function which calls a method binding this for you. And so that makes it easy to pass methods into callbacks. And that's a good thing. So that's now standard equipment. Oh, and the way I wrote this is a way you might, if you're an author of an Ajax library, you might consider adding this to your library. So first thing I do is ask, does this already exist in my system? And if it does, then I don't do anything because I don't want to replace the native version with my stupid version. We have string.trim. So you can now finally bring it up. There's now finally a standard way of taking the excess white space out of strings. We have a large set of new array methods, which are higher order methods in that they take a function and apply that function to every element of the array that you're acting on. And that turns out to be a really elegant way to use arrays. So you don't have to use for loops anymore. You're just doing all this function stuff instead. There's some people who complain that it's too slow, you shouldn't do that, and that's ridiculous. That you don't spend that much time in the overhead of this stuff, and the elegance that it empowers your code with is just amazing. So the first one is every, which is sort of an and function. It keeps going through until it finds one that's false, and then it stops. Mozilla came up with this in Firefox. That's the first place that it occurred. And I think they made a big mistake when they designed the API of these things. And that is that when they're calling your function, they pass not only the current value, which is all right, and the current subscript of that value, which is all right, they also pass the array itself, which is that read this in this case. And that gives that function more privilege than it needs. It violates the principle of least authority, that it doesn't need the whole array, it only needs its one element to do its work. Now, it's not a serious thing because you probably have control over the function and the array, so it doesn't look like a big security violation. But still, it's bad in terms of design patterns. So we left it in because there are people in the Firefox community who were using these methods, and we didn't want to break them. So we're kind of stuck with that. So we're encouraging the browser makers to do experiments in their browser so that we can test new features in the wild. One of the occasional drawbacks of that is sometimes a bad API will get into the standard as a result. We have filter, which goes through the array, and if an element, and if the function returns true, then we pass that value through an array. So you can remove things from an array, which is really nice. We have for each, which is a direct replacement of the for statement. I really like for each. We have index of, which is sort of like string index of, in which you can search for a value within an array. And last index of, which starts from the other end. We have map, which is like for each, except it takes each of the return values and puts them into an array. So it allows you to simply do transforms on arrays, produce new arrays. Really, really nice function. Reduce, which allows you to do, if you pass to reduce a function like add or multiply, it will give you sums and products. It's a very nice thing. Then there's reduce going in the other direction, which doesn't seem very useful to me. And sum, which is the opposite of every, it's an or function. We have date.now. So if you're trying to do timing in the browser, it used to be that you had to create a new date object just to extract the current time. And so you're adding a lot of latency into the very act of trying to figure out what time it is. And that's not good. So now you can get now immediately. One problem with the language is that it's never had a formal definition of date formats. When the early standards were made, Microsoft and Netscape couldn't agree on the formats of dates, so they agreed to leave it underspecified in the spec. So there's no guaranteed date format that's going to work in every browser, at least according to the standards. So we fixed that. Every browser going forward, implementing ES5, will now understand ISO dates, which is the best data processing format we have for dates. So we've got two ISO string, which will produce a standard ISO format, and new date and date parse will now accept that format as well. They will try to format or recognize ISO format first, and if that fails, they will then do their proprietary methods. We finally have a way of determining if a value is an array in the language. We've never had that before. Yeah, thank you. So array.isArray. It's unfortunate that the name is that long, but doing it any other way would have introduced new syntax, and we didn't want to do that, so we're kind of stuck with that. Maybe in the future we'll have better syntax for that. We have object.keys, where you pass it an object, and it returns an array containing all of the own enumerable keys of that object, which you can then go and pass to one of those array methods, which is a really elegant way of dealing with enumeration, much better than for in. For one thing, it's immune from the inherited method problem, because it only looks at the own methods. Now, ideally, this would have been hung off of object.prototype. So you'd say object.keys, or my object.keys, and do it. We didn't do that because there was a very high likelihood that some applications have properties called keys, and that collision was going to cause failure. So we instead put it on object.keys, which is a less convenient place, but we didn't have anywhere else to put it. We have object.create, which is an important thing because this is the primitive of prototypal inheritance, where you can create a new object that inherits from another object. JavaScript was always confused about its prototypal nature and had a pseudo-classical syntax for doing this very prototypal thing. So now it's all prototypes, so that's a really good thing. We have a meta-object API, which gives you control over the attributes of the properties of your object. Now, in the ES3 specification, there are attributes on properties, and it describes three of them: don't enum, read only, and don't delete. And when set on a property, they do the obvious thing. They prevent it from showing up in the for in enumeration. They don't allow you to change it, and they don't allow you to delete it. And those are really valuable things, and unfortunately, they didn't expose them to you. So there was no way that you could turn those bits on. they were required by the model, and the implementations could use those bits, but you couldn't. So we changed that in ES5. So now finally you've got more control over that stuff. So you can make objects which are more durable and better. So we now have two kinds of properties in the language. We have the data properties that you're used to, and we have accessor properties. Accessor properties are properties that use get and set. So we now have 6 attributes, and 4 of which will be in data properties and 4 will be in accessor properties. So data property can have a value, it can have writable, which is a Boolean, it can have enumerable, which is a Boolean, and it can have configurable. Configurable determines whether you can delete it or change it to another kind of property. And then the accessor properties can have enumerable, configurable, get, and set. The Boolean property, or the Boolean attributes, once they are set to false, can never again be changed to true. So if you set a property to a writable property to false, that means you could give it to untrusted code and be confident that that code cannot change the value of that property. So that allows us to be much more resilient. The way in ES3 you could create an object would be using an object literal. Here I have a property named foo with a value that is bar. In ES5 you can now write it this new way. And you might be looking at that and go, holy crap, I mean that's a whole lot more code and a lot worse. How is that an advantage? It's an advantage because you now have control over those new attributes. So here I'm setting writable, enumerable, and configurable to true, but I don't have to. I could set them to false at this point, and then they will be false forevermore. So maybe in future editions we'll have some more elegant syntax, so you could do this while you're defining object literals. We couldn't do that in this one because we're trying not to produce new syntax. So we didn't make it convenient, but at least we made it possible, and so that's a step forward. We have a similar thing that we can do with accessor properties. So you can call object.defineProperty, and you pass to it an object that you want to manipulate the name of a property that you're going to manipulate, and you pass it an object which describes the attributes that you're going to be setting. In this case, I'm going to add a get function, a set function. I'm going to set enumerable to true, and by implication, I'm going to be setting configurable to false because I didn't specify it, so false is the default. And so that says that this property will show up in enumerations, but you cannot delete this property and you cannot change it to be a different kind of property or change its getters and setters. So in the Meta Object API, we have object.defineProperty, which you pass an object, a key, and an object, which is a descriptor of the attributes of that property. If you want to do a whole bunch of them at once, as a convenience, we have object.defineProperties, which takes an object of property descriptors, where in the outer object, each property name is the name of a property in the next object, and its value is an object descriptor or a attribute descriptor, which will describe how the property will be created. We can get that data back now by calling object.getOwnProperty descriptor. You pass that an object and a key, and it will then return an object which is similar to the one that you could have passed to define property. In addition to those, we have a couple of methods that you probably won't get to use. One of them is object.getOwnProperty names. This is similar to object.keys, except it returns all of the objects, or all of the property names, even the ones that are not enumerable. And we also now have getPrototypeOf. You pass that an object, and it returns the object that it inherits from. These were added for the benefit of security programs that want to be able to go through the environment and find everything that the implementation provided and modify it or lock it down in order to create secure applications. And in the process, what they will likely do is make copies of these methods and then delete them from the system so that you won't be able to get at them. And that's because they're security properties of the browser that we're trying to enforce that we could not enforce in ES3. So having these things, it now becomes possible to do things we couldn't do before. For example, suppose I've got an object and I'd like to change its prototype. I can't actually change the prototype of an object, but I can create a new object that contains all of the same stuff as the previous one and have that object have a new prototype. So I can use object.create to make the new object, and then I can use getOwnProperty names to find out all the members of the object, and then use for each to copy all of those properties from one to the other. And this will work even for things that are read-only and things that have getters and setters on them. We also have control now over the extensibility of an object. So in ES3, any object, anytime, you can add a new property to it. And that's a very nice feature. But there's some times when you want to prevent that. So we now have object.prevent extensions. You pass out an object, and it will now cause an error if you try to add new things to that object. We also have object.seal, which does that and also sets all of the properties of the object to be not configurable. And we have object.freeze, which does the same thing as seal, but it also sets everything to be not writable. So that allows us to have, finally, immutable objects in the language. Now, by some interpretations, we've always had immutable objects, like strings and numbers and booleans are objects in this language that you cannot modify. Now you can define your own immutable objects in the language. In the future, we may see some optimizations that happen as a result of that, because compilers could be very clever about what sort of actions you have on immutability. But for now, we're looking at it mainly as a security feature, where you can give an object to some untrusted code and be confident that code can't damage it. Then we also have predicates which allow you to determine if we've done any of those things to an object. Is extensible, is sealed, is frozen. We have, in ES3, we've got the unintended inheritance problem. So here I've got a little application where I want to count words. So I've got a word count object where the keys will be words that I find in a text, and the value will be the number of occurrences that we found. So then I will use a regular expression to split my text on white space and punctuation, and I will take the array of words that results from that and then use for each to go through and count each of those words. This fails if one of the words in my text was constructor, because it turns out all objects inherit something called constructor, which is a function that was used to create that object. In some cases, it'll be the object function. So our increment will fail when the word is constructor. And there are lots of other accidental inheritance problems in the language as well. So in ES5, we have some solutions to that. One is we can pass null to object.create, and that will create an object that inherits nothing. It has no methods, it's got nothing. So it's completely empty, and you can do whatever you want with it, and you can be confident that any value that you read from that object is original with that object. It wasn't inherited from any place. Prototypal inheritance is very often a useful place or a useful technique, but sometimes it gets in the way. So this allows us to easily get it out of the way. We can now, if you're adding methods to prototype objects, you can now set those properties to be non-enumerable, so they will not show up in for-in enumerations. So that's a nice thing. And we have object.keys now, which automatically does the has-own-property filtering for you, so you don't have to do that. The most important feature in ES5 is strict mode. This will allow us to solve the mashup problem and very elegantly allow code from third parties to run on a page without compromising the security of the site or the user. This is a really big, important step forward for the language. The way you specify strict mode is with a backward compatible pragma. We use a useless string expression statement, which is something which is allowed in ES3 but doesn't do you any good, where you can just say the name of a constant, semicolon, that's a statement, not an error. So we took advantage of that. So if you have use strict as a string in your program, it is ignored by ES3 processors because they think it's nothing. But in ES5 processors, they go, all right, this guy's smart. We're going into strict mode. So it allows us to be working in a compatible subset. So it gives us backward compatibility. So you can be writing for ES5 strict, but still run on IE6. It has two forms. One is the file form, where if use strict is the first statement of a file, then all of the code in that file is considered to be strict. And there's a function form, which is if the first statement of a function is use strict, then all of that function and any inner functions it may have are strict. I recommend using the function form and not the file form, and that's because of Steve Souders. Steve Souders has been doing a lot of work in the performance of web applications, and one of the things he observed was that the way browsers acquire and load scripts is really inefficient. So he declared a rule in which you try to minimize the number of HTTP transactions you do. And for scripts, the way you do that is you take all of your scripts and you concatenate them together into one file. The problem with that is that it breaks the strict mode pragma, because if the first of the files was strict, then it's going to assume that everything that in all the other files is going to be strict too, and that might not be the case. In fact, we've already seen some famous websites get messed up by that. The right way to solve that would have been to fix the browsers, but that would require that W3C do its job, and that's not what it does. So instead, we've always done the best we could with what we had, and sometimes that forces us to accept practices which are in hindsight not so good. But fortunately, we have the file form, or the function form, which allows us to contain the strictness. So you can then concatenate these things together, and strictness does not contaminate from one file to another. So that's a good thing. So strict mode doesn't add anything. Mostly it's subtracting things or repairing things in an incompatible way. So this isn't a feature that you've been clamoring for, but this is something that corrects some of the deep problems in the language and allows us to go forward in a much better way. So one of the restrictions that you're going to get is a new set of reserved words. And it may be that some or all of these words will be reserved in the next edition of the language, or will be used in the next edition. I can't promise that all of these will be used. Pretty likely let will be there. Not sure about the others, but we'll see how that turns out. Then there are a lot of little things that happen. All of these are breaking changes. No more implied global variables within functions. So one of the terrible things about, bring it up. One of the terrible features of ES3 was that if you have a function where you forget to declare a variable, it assumes that you meant a global variable in that case. And so your program just keeps rolling on and causing trouble and panic and mayhem. That was intended to make the language easier for beginners because they don't ever have to declare variables. That turns out to be a terrible practice, not something we should encourage. So that doesn't happen anymore in strict mode. This is no longer bound to the global variable when you call a function as a function. Instead, this will be bound to undefined, which is what it should have been, so that's good. Apply and call, it used to be if you passed null as the this value to apply and call, it assumed that you meant the global object, which is, again, wrong. So now it'll just pass the value that you passed through without modification, which is right. The with statement is gone. A lot of people like the with statement. It turns out it's unnecessary, and just by being in the language, it makes everything slower. It's because ES3 was confused about whether variables were loosely scoped or strictly scoped or dynamically scoped. So it kind of did it both ways. It turns out statically scoped is the right way to do it, and so that requires getting rid of with. Getting rid of with also makes it much easier to analyze programs and determine what they're going to do, and that will become important for reasons I'll show in a bit. In ES3, if there's a property which is set to read-only and you try to change it, nothing happens. So it acts as though it did, but then the program keeps going. And so that can cause programs to get into an inconsistent state. In ES5 strict, it'll throw an exception, which is the right thing. So if you try to change something that's read-only, including changing the new, like now if you try to set undefined to 5, you'll get an exception, which is the right thing. And similarly, trying to delete something that was marked as don't delete, that will now throw an exception. It won't pretend that it did it and not do it. There are new restrictions on eval. Eval in ES3 can do terrible things. You can go into the function that called eval and mess with it. You can add new variables to that function. You can delete variables in that function. There's no security around eval at all. It's quite awful. It is by far the most misused feature of the language, and we would have been justified in taking it out entirely. But instead of removing it, we corrected it. So eval now runs in its own scope, so it doesn't get to pollute the rest of the system, so it's much safer. There are big restrictions on how it's used. Eval and arguments join the set of reserved words, so you cannot have a variable called arguments or a variable called eval. Arguments are no longer linked to parameters. So there's the really weird thing in ES3 where if you change the value of a parameter, the equivalent value in the arguments array will also change, and vice versa. And you can do really weird things like if you unshift the arguments array, all of your parameters shift. That's nuts. And the implementers of JavaScript engines hate that because that's maybe the hardest thing about JavaScript, not only to implement, but to, how can you make JavaScript engines go fast when that kind of crazy stuff can happen? So one of the benefits of ES5 strict is it will make it easier for JavaScript engines to get faster as we go forward. The arguments array no longer has a caller property or a callee property. These caused capability leakages, which are problematic for security. And it was difficult taking them out of the language because in the case of arguments.caller, it was never in the language. So there's no sentence we could go to and delete that sentence because it wasn't in the standard. So instead we had to say, when you're in strict mode and you have an arguments object, then you have to put a property on it called caller, and its value has to be null, which is goofy, but that's how we had to do it. Let's see, no more octoliterals. Octoliterals haven't been useful since computers had 6-bit bytes, but for some reason they keep showing up in every generation in every language. And they are useful only to attackers because there are confusion attacks around them. So we're taking those out. And something that should always have been a syntax error, if you have an object literal with two properties with the same name, that's now a syntax error. And if you have a function with two parameters with the same name, that's a syntax error too. Somehow that was allowed in the old one. So one of the benefits of all of this stuff is that if you now forget to use the new prefix when you're calling a constructor function, instead of clobbering global variables, you'll now get an exception, which is the way it should have always done. So my slogan on this is death before confusion. We don't want programs going ahead thinking in an inconsistent state, thinking that everything's fine when it's not. Instead, we want the programs to stop so we have a chance to fix them before they cause more damage. I think death before confusion should be the motto for next year's show. So one of the breaking changes that this introduces is it used to be in ES3 browsers, you could call add event listener just as a naked function in order to add event listeners to the window object, because window is the name of the global object in browsers. That doesn't work now because this value that's passed to add event listener is now this and not the global object. It should never have worked, but there was this accident in the way the language was misdefined, which allowed it to work, and some people have taken advantage of that, but no more. So now it's necessary to say window.addEventListener if you want to add an event listener to the window. So this is a case, another instance of a breaking change which is introduced by ES5strict. There's no built-in methods in ES5strict for determining if you're in strict mode or if you're in a language processor which can have strict mode. And we couldn't really put it in anyway because those wouldn't be available in the old browsers, and so it wouldn't make sense to call them anyway. But they're trivial to create yourself. So you can have an in strict mode function which calls a function and then looks at the this value, and that'll determine if you're strict or not. And you can do a similar thing to find out if strict mode is implemented in your environment by doing that same thing with a strict function. If you're using JSLint, and you should, then the transition to ES5strict should be pretty painless. There's a large overlap between what JSLint thinks is good practice and what strict mode thinks is good practice. It's not complete, though, because JSLint does a static analysis, and strict mode can do a lot of dynamic stuff. So JSLint can't catch everything that can go wrong, but it will catch quite a lot of it. So the most important thing, most important direction, I think, in JavaScript software development is mashups. Mashups are where you've got code from multiple parties that were not designed to work with each other, but which run together in some environment, each representing a different interest. And this has been the focus of research in software development for decades. And almost accidentally, it just came to life in JavaScript. JavaScript seems to have exactly the right set of properties in order to implement this. It's just the right bit of looseness, and you get the functions and everything, it all works. But there's the problem of the cross-site scripting problem. And a mashup is a self-inflicted cross-site scripting attack. So each of those components gets access to everything that's in the browser. Everything the page can do, each of those third parties can do, and that's too much power. And so the ability to do mashups is greatly restricted because of that. But we need to mash up, and we're going forward anyway, and so we've been compromising. So one technique that we've used is with safe JavaScript subsets, that there is in JavaScript a safe subset language. If you take out all the things that are the sources of insecurity, what you're left with is something that's secure. There are a number of projects that did that, including one developed at Microsoft called the Web Sandbox, which is very, very good work. The two that I'm most familiar with are Kaha. Kaha is used at Yahoo. So on our front page, we've got third-party widgets, and they are processed by Kaha. Kaha is a JavaScript to JavaScript translator, which translates untrusted JavaScript into trusted JavaScript. And in doing that, it adds a lot of runtime checking to the code it produces and a lot of indirection and other techniques to give us confidence that that code cannot get out of hand. The other one is AdSafe, which is something I developed, which is based on the same capability theory as Kaha, but takes a different approach, where it uses static analysis to remove all the bad parts from JavaScript so that no transformation is necessary. The advantage of that is that Kaha makes code much more difficult to debug because the code you're debugging is not the code you wrote, it's the transformed code. And it can significantly slow down the performance of the code. Whereas AdSafe, because it does no transformations, your code is the code that runs. And so that's a huge advantage. The disadvantage with AdSafe is that it deletes a lot of stuff from the language. It deletes this, it deletes subscripts. Now, it turns out the language that's left still contains functions, and functions are all you need to write great programs, so it's useful. But the number of existing programs that are likely to run through the AdSafe verifier is 0. So you have to be writing for the AdSafe rules. So what strict mode does for us, it allows us to have the advantages of Kaha and AdSafe together, where we can have the much larger version of the language, but we can have the convenience of the static validation that AdSafe can do. So by doing a single run through a testing program, we can determine that a program is safe to put on our page. So the benefits to us are huge. And so we can only do this because we now have strict mode. Without strict mode, we're forced to use Kalha in its old way. But then there's the IE6 problem. So the past is the enemy of the future. We want to go forward, and it's hard to go forward because IE is still here. Now, 10 years ago, IE6 was the best web browser the world had ever seen. It was vastly superior to everything else that had ever occurred, and remained the best web browser in the world for at least another 5 years. Since then, it has not aged well. And it is now the thing that holds us back. So all of the goodness that I'm talking about, you don't get it with IE6. And IE6 is still a significant part of the market. We see more people coming to Yahoo on IE6 than Opera, Safari, and Chrome combined. We had a similar thing with Netscape 4. Netscape 4 was Netscape's last attempt to make a web browser, and it was a crime against humanity. They thought that getting to market first was going to be the thing that was going to make them win, and it didn't, because they went to market with crap. But it took many years for it to evaporate out of the market. So everything that we needed to do Ajax was available in the field in 2000, but Ajax didn't happen until 2005. And I think the reason for that was it took that long for Netscape 4 to diminish to irrelevance. Because trying to do Ajax on Netscape 4 was just impossibly difficult. So in 2005, I predicted it would probably take 5 years for IE6 to evaporate. And it's past that time, and it's still here. So its numbers have declined, but not very quickly. And there are a number of reasons for that. But the fact is, it's still there. And until we get rid of it, it's going to be really hard to go forward. And life gets worse for web developers, because you've got clients who are looking at all this well-new HTML5 stuff and saying, yeah, we want that, and yeah, make it work on IE6 too. And that's just impossibly difficult. So somehow we need to get rid of this thing, because it's dragging us down. So what's next? What might we see in a later edition? At this point, nothing's certain yet. We're thinking the next edition might be published in 2 years, but no final decisions yet on what might be in it. I would expect to look for lighter, more expressive syntax. JavaScript is dominated by its C heritage, which is ugly and cumbersome, and I know we could do much better. I'd like to see some of that get into the language. We'll probably see more expressive object literals, which will let you do more of the meta object stuff in a nicer way. I'm hoping we see tail recursion, or proper tail calls, which would allow us to do continuation passing and really elegant functional programming in this language. That would be a huge advance. I think we're finally going to get a module system in this language, so we're not dependent on a single global object for binding all of our stuff together, that we can actually define good interfaces between components and allow us to reason about those well. We'll have probably proxies, which are a form of catch-all, where if you try to access a property of an object that an object doesn't have, you can arrange for something else, something wonderful to happen instead. We might fix the type of operator, so the type of null will be null. And much more, probably. And in fact, my biggest fear is that it'll have too much more. We're looking at a lot of features, and every one of them is wonderful. And I'm pretty confident that if we do all of them, it's going to be terrible. So I think JavaScript wants to be a small language, and so we need to be careful not to put too much gunk in it and mess it up. And what criteria we have for doing that is difficult. We haven't figured out what that is. We've talked about a complexity budget, but we have no way of quantifying it or enforcing it. But in talking to you today, it occurs to me that maybe what it should be is we shouldn't have any more new features than you could talk about in an hour. That'd be maybe the right size for the next version of the language. So until then, thank you and good night. So we have a little time if you want to come up to the microphones. Okay.
Is it on?
Yeah,
There we
you're
go.
on.
The question is, what about providing support towards browsers to implement a sandboxing for third-party scripts? So if I include my Twitter script, I don't have to worry about it impacting me. And knowing that it's third-party, I can tell it to be implemented on a sandbox.
I think that's an excellent idea, and I wish the HTML committee had done that. They went in a different direction instead. We have significant security problems in the browser model, and I think they should have solved those before adding a lot of the stuff that they added. In my view, that was irresponsible, but that's what we got. So in my experience, ECMA is a much more responsible organization, and so we're doing as much as we can with ECMAScript to solve these problems. We tried to have joint meetings with W3C. Mostly our attempts to talk to them were, why should we have a meeting? Or we don't even meet with each other, why would we meet with you? You know, that kind of stuff. We did have one meeting last year, which was completely unsatisfactory. And the one result of that meeting I thought was going to be, we should have another meeting. But we didn't even do that. So there's this big gulf between the W3C's standards and the ECMAScript standard. There's a lot of the browser that is not adequately specified anywhere, and much that is specified is wrong. I'd really like to get that fixed, and I can't. I tried to interest ECMA in a turf war and said, well, W3C is doing a lousy job. Why don't we do it? And they go, well, maybe we don't want to do that. So we do what we can. Thank you.
Thank you.
Anybody else?
As far as the pace of the innovation here, if there's a new release that comes out in, say, 2 or 3 years that has a lot of new features, won't there be a problem that, I mean, there's a very good chance that nobody's going to deploy most of ECMAScript 5 by that point, or at least most people won't be using it. So how do we balance that?
Our hope is that we get the whole world onto a faster auto-update regime. We have to do it before the next edition comes out, possibly the 6th edition, because if IE6 is still an important player at that time, then ECMAScript dies as a future-facing language, because yes, the next version cannot run if IE6 is still in the world. So we need to get past that. I'm hoping that, you know, I'm not worried about IE9. I mean, I have a big problem with IE9 not having strict mode in it. That's tragic. But I think IE9 is going to fade away almost immediately once IE10 comes out. So that doesn't worry me. My worry is that IE6 will still be here after IE9 fades away. Yeah.
Speaking of the ISO dates that you showed earlier, are we ever going to get a date literal in the language, especially so we can transfer it in JSON?
You're not going to get it in JSON because JSON is frozen. So JSON will never change. Now, maybe at some point we'll decide that a new format should replace JSON, and maybe it will be JSON-like, and maybe it'll have date literals. Currently, there's no plan for that.
Can we do it, please?
Yes.
Hi. So I know you were talking about the functional properties that are going to be available. I've also read about some of the other things that JavaScript will be able to do, like list comprehensions or array comprehensions. So I wanted to get your opinion about some of the overlap of the abilities to use either, you know, map, filter, reduce versus, you know, like an array comprehension.
I would like to see the language become more expressive, so that you know, a feature which let you do 10 lines of work with 1 line looks like a huge win to me.
Yes.
A feature that lets you do 10 lines of work with 9 lines, I'm not sure it's worth the trouble. So my preference is that we tackle high-value improvements to the language. I'm also in favor of anything which makes the language easier to read and comprehend, because I think that's more important than anything else we can do with the language. But at this point, I can't predict what the next edition is going to look like. It's still too murky.
Thank you.
Okay, it got 16 seconds, so I think that's probably the end. So sorry, maybe we can talk later. Thank you.